So, hello and welcome to this short tutorial. Trust me, it's a very short one, I promise. I just want to show you how you can include stochastics in your deterministic model. So I've opened the basis model, the one machine model, and let me start with the processing times. Here we can see the delay time is the parameter process time station 1. So in this case, a deterministic behavior. Now I cancel that one out, and I would like to have exponential distributed interval times. So the function for exponential is exponential. Then it takes a while. Then I select the first one, and then I have different options. So you can select double lambda. This one we are going to use. But you can also see that there is a possibility to find a minimum value or a maximum value, because perhaps there is a high probability, if you recall the density function of the exponential distribution, that there is a high probability that very low values are returned. And if you don't like that, then you can define a minimum value for that. And unfortunately, there is also a possibility that very large values are returned by the exponential distribution. The probability is low, but there is the probability. So it could be that you get processing time back with 1000 time units. And if that happens in our case, we would have troubles, because then we can only process this one order and the rest is queued in front of the machine. So we are selecting that one. And then we have to define lambda. And lambda, if you don't know that, you can use the help, the logic help. Where are you? Then we're searching for exponential. We take the first one. And then you can see all the options which are available. So I select the double lambda, and then we can see that AnyLogic needs the shape parameter, which is the rate. We have to define the rate. And we just have the processing times, the interval times. And the rate is defined by 1 divided by the processing times. So please don't forget that, 1 divided by the parameter processing time. Where is it? Here is it. The 1.0 is needed that AnyLogic recognize that I would like to have a double division. If you don't use the 0.0, then you do a casting and integer division. Yeah? And if you get the return value of 0.4, for instance, back, then you get the cast. That means the result is a 0, and that's what we don't want to have. So, and now we can do the same procedure for the source. Here as well, you can see that the interval times are deterministic, so I comment that out. And I activate what I have already there, so you can do the same. So exponential 1 divided by the parameter arrival time, which is the interarrival time of our orders. And if you would like to have, or if you, according to the outline of the assignment, I'm sure you don't like that, but according to the outline, you have to do it. There is also a stochastic due date needed. And in my circumstance, it's already activated. So I'm calculating the due date based on the arrival time. And then I use the exponential distribution function of Java. And the argument is 1 divided by the parameter due date horizon, which is, again, an interarrival time for the due date horizon. 1 divided by interarrival time is a rate. So you always have to make sure that the return value is a rate for the exponential distribution. Thank you very much for listening, and enjoy modeling in AnyLogic. Good luck.